Hey guys, we are on Unit 9 and this is day 5. We're going to do volume of pyramids. So we're going to say find the exact volume of the solid below, and we're going to have to realize that this solid is made up of a cone on top and a cylinder on the bottom, and then we're going to add them together to get the total. So we're going to set this up as the volume of a cone plus the volume of a cylinder. All right, to the formula sheet, volume of a cone is 1/3 pi r squared times height, plus the volume of a cylinder, which is just pi r squared times height. All right, all we have to do is fill this in. So we're going to go ahead and go to the cone, and we're going to say 1/3 pi. The radius, you guys can see that in the cone, the radius is 8. Don't forget to square it. And then we're going to multiply by the height. We don't have the height. In that cone, they gave us 17, and that 17 is known as our slant height. And we can't insert 17 in for a height because it's too long. Okay? We'd rather have this line segment right here and have the measurement for it. If you notice, the 8, the 17, and the height actually form a right triangle. And since we know two sides of that right triangle, we're going to take a side step. We're going to do a little a squared plus b squared equals c squared. And then we're going to go ahead and make sure that 17 goes in for c because it's the hypotenuse of the right triangle. And 8's going to go in for a. Or it could go in for b, it doesn't matter. Okay? We're going to get 64 plus b squared equals 289. We're going to take a 64 away from 289 so that we're left with 225. And then we're going to go ahead and take the square root, and b is going to come out to equal 15. And that 15 is now our height, and we'll get rid of the 17 so we're not tempted to use it. Okay? And now we can go ahead and put that 15 in for our height for our cone. Okay? If we finish the math off here before we go to the cylinder, we're going to leave it in terms of pi because they asked for the exact volume. So pi is going to stay on our paper. All right. Everything else is going to go into our calculator. So we're going to type in the 1/3 times the 8 squared times the 15 and hit enter. And we're going to get 320 pi because pi didn't go in our calculator. So it has to be next to the 320. Okay. And then we're going to continue on with our formula. And we're going to add to the cylinder volume to that. In our cylinder, we can still use that 8 as not only the radius of our cone, but it's also the radius of our cylinder. Don't forget to square it. And then looking at the cylinder, this 12 right here represents the height of our cylinder. Okay, just to keep things consistent and so that they end up exact, the pi is going to stay on our paper. And we're going to type in 8 squared times 12 to get the volume of the cylinder in terms of pi. And when we type that in, we get 768 pi, since pi didn't go in the calculator. Okay. And since both volumes have pi in it, that makes them like terms, and we'll be able to go ahead and add them together. So 320 plus 768 is going to give us 1,888 pi. And that is our volume. Okay. And so this will be units cubed. And there's the total volume of the cone on top plus the cylinder on the bottom. Okay. All right, let's go ahead, guys, and talk about pyramids. So volume of a pyramid is given to you on your reference sheet. And the volume of that pyramid is 1/3 big B times H. And so we get that big B again like we had in prisms. And we have to remember that big B is the area of whatever the base shape is. So whatever shape it is, we have to find the area of it and then insert that for big B and then multiply by the height of the pyramid and multiply it by 1/3 out in front. Okay, just like the cone with the pyramid, they could give you height, which is what we need for the formula, or they could give us slant height like they did in the warm-up. Okay, slant height in a pyramid looks like this. Pretty similar to what it looked like in a cone, all right? It is the hypotenuse of that right triangle that's formed by the height and half the base rate. Well, you can't say radius because it's not a circle on the bottom, but it almost looks like a radius because it goes from the center of the shape to the edge. Okay, so that's how we're going to go ahead and figure that out. All right, so let's go ahead and take a look at some examples. And in number 1, we have a regular pyramid with a square base, as shown in the diagram below. A side S of the base of the pyramid is 12 meters. So because this shape on the bottom is a square, all sides of that square are 12, since square has all equal sides. Okay? And the height, so nice normal height, this nice dashed line going straight down, is 42 meters. Okay? They want to know what the volume of the pyramid is in cubic meters. So volume of a pyramid, we go to our reference sheet, we write down 1/3, big B times H. Okay? Just like prisms, we take that big B off to the side. Big B, remember, stands for area of the base. And in this case, the base is a square. And formula for a square or a rectangle is base times height. And so that square has dimensions of 12 by 12, and therefore it has an area of 144. This 144 can now go back in for B. So now our volume will be 1/3 times 144 for the area of the base times the height of the pyramid, which is 42. Okay? Everything's going to go in our calculator, so we're going to type in 1/3 times 144 times 42, hit enter, and we end up with 2016 meters cubed, since it's a volume. And there's the volume of our pyramid. Okay? All right, let's go ahead and take a look at number 2. And in number 2, it is talking about a pyramid shown below with a square base again, and a height of 7, and a volume of 84, and they want to know the length of the side of the base. Okay? So we'll go ahead and go to our formula because they're talking about volume of a pyramid, and we'll write down the formula, 1/3 big B times H. Okay? This time, though, that's a work backwards one since they tell the volume is 84. Keep the equal sign, keep the 1/3, and then big B. Big B will take off to the side, and big B is the area of the base. And our base is a square, just like it was in the last one, which is base times height. However, in this one, they didn't tell us the length of the side of the square at all. However, we know that whatever the square is this way, the square is same length as this way. And so we can type in x times x because that's actually what we're solving for. And we're going to turn that into x squared. And we're going to take that back and put that in for big B. Okay, and then our height is 7. All right, so we're going to clean this up a little bit. We're going to leave this as 84. But on this side, we're going to type in 1/3 times 7. And when you hit enter, it's not the prettiest. It's 2.3 repeating. And remember, you can't round that. So we're going to keep the 2.3 repeating times our x squared. We're going to then divide by 2.3 repeating. Just remember, don't divide by 2.3. Make sure that it's repeating, okay? And that's going to end up with 36 equal to x squared. Then we're going to go ahead and take the square root, and x is going to come out to equal 6. And so the side of our square equals 6, and there is no units in this one, so we'll just say 6 units. All right, so therefore the area of our base would have been 36 if they asked for it. Okay, all right, I will see you guys on the back side of notes.